Hello, I'm going to talk to you about the binomial distribution. This is how the binomial distribution works. The experiment has only two possible outcomes. One is considered a success, the other one is considered a failure. Each outcome has a fixed probability of occurring. You can either have a probability, well, the probability would be P. Then the failure must be 1 minus P, since all probabilities must sum up to 1. And each trial must be independent of any other trials. They cannot be dependent on each other. So those are the rules. You have two possible outcomes, success or failure. The probability of success is P. The probability of failure is 1 minus P. And the trials are independent of each other. So this is the long version of the binomial distribution if you do it by hand. And as you can see, that looks pretty nasty. You have this symbol here. That's a combination. I discussed combinations in another video and I gave it to you guys. It's the same as this. Now you can choose to do this by hand if you want to, but it's easier to do all of this in Excel. So let's look at an example. What is the probability of getting 7 heads and 10 tosses of a coin? Well, this is a binomial distribution. The first thing you have to do is identify if it's a binomial distribution. So you can either get a head or you can get a tail. So that would be a success or a failure. Heads would be considered success, tails would be considered a failure. Tossing the coins are independent of each other. If I toss one coin, that's not going to affect the outcome of the second toss. And what else did I want to say? Well, let's write this down. Oh, the probability of getting a head is 0.5. So probability of getting a tail is 0.5. That's success. The failure would be 1 minus 0.5, which is still just 0.5. Okay, so this I'll put up here. This is 1 minus P. Okay. So we're going to do this in Excel. And this is the generic version, or the generic formula for it. First, you got to figure out the number that we're interested in, the number of trials, the probability of success, and whether or not it's going to be cumulative. If we're looking at exactly 7 heads, we're going to call cumulative false. You have to put a word in here. It either has to be false or true. Okay? The probability of getting a head is 0.5. We're looking at 10 trials, and we want to know exactly 7 heads. So I wrote out the version that you would type in Excel. Okay. And I guess I can show you how to do that in Excel. Let's see if I can switch over. I'll move this over here. I guess you guys can see that. Oops, put it back. So I have 7, 10, 0.5, and false. And as you can see, this is my answer, 0.117188. Alrighty, see if we can go back and move this over. Okay, so now let's do a different problem. I got to move this over some more, just a second. There we go. So now let's figure out the probability of getting 5 and 7 heads, between 5 and 7 heads and 10 tosses of a coin. Now with this one, you have to do each individual number in Excel. So you have to do 5, you have to do 6, and you have to do 7. So I put the commands on there. All you have to do is just put that in, I'm going to give you the answers for each one. So let's look at the first one. When I did it in Excel, I got this 0.246094. For the sixth one, I got this. And then for the seventh one, I got, we just did this one. And so to get the answer, what you have to do is you have to add up all these numbers. And I get 0.56836. So the probability that you get between 5 and 7 heads and 10 tosses of a coin is 0.56836. So you can just round it 56.83%. I'm going to go back to this last screen. We said it was 0.117188. Or you can say 11.72%. So the probability that you get 7 heads and 10 tosses of a coin is 11.72%. Okay, so that's how you would do the binomial distribution. Once again, I would suggest that you do it in Excel. You use that long formula, you're going to lose your mind. Okay, hope this helps.